One of the strengths of multiple regression is that it's a powerful tool for statistically controlling for the effect that other variables may be having on our results. But what exactly is statistical control and how does it work? In this series of videos, we'll explore that very question. But let's begin by examining what we mean by control in the first place. To understand statistical control, it may help to briefly revisit the idea of true experimental studies where we randomly assign participants to different conditions or different levels of whatever variable we're studying. Random assignment provides what's called experimental control. For example, I'm currently involved in a study testing a new math program versus a school's current curriculum. We're randomly assigning students into these two conditions, the current curriculum or our new program, because there's good reason to believe that if we just let parents and teachers decide, the more engaged, more informed, more educated parents might push to have their child in the new program. And similarly, the more engaged teachers may be the ones who sign up their classes for the program in the first place. And if that happens, then whatever we find, even if the program seems to work, we're left wondering whether it's due to the program or whether it's due to more educated parents and more engaged teachers getting their kids and students into it. We're kind of stuck. That's why we like experimental studies where we randomly assign participants into different conditions. Random assignment removes the impact of all of the other possible factors that could be the real reason why we see an effect. Think back to our video on spurious correlations, ice cream sales, and drowning deaths, right? It's a powerful, almost magical, and methodologically beautiful tool. But in reality, you can't always randomly assign people into different levels of whatever it is that you're studying. For example, in the past, I studied the impact of smoking while pregnant on child health and development. I can't randomly assign pregnant women to smoke or not smoke, and I wouldn't want to. So, what do? That's where statistical control comes in. Random assignment experimentally removes the effect of the other variables, experimentally fixing, taking care of any effect they may have on our results. When we can't randomly assign, statistical control lets us mathematically remove the effect of these other variables in our model. It's a workaround for when we can't randomly assign participants to different conditions or different levels of whatever it is that we're interested in. So, how is statistical control related to multiple regression? In fact, statistical control is an inherent part of any multiple regression analysis. In multiple regression, the regression coefficient is the effect of one specific variable statistically controlling for all of the other variables in the model. That's why in previous videos, when we introduced multiple regression, you may have noticed that once we had more than one variable in our prediction and one predictor variable in our model, we started using language like the effect of school quality controlling for study hours or the effect of study hours controlling for school quality. Now, there are several ways that you can think about or conceptualize how statistical control works. So you may hear or read people talking about it in different but fundamentally equivalent sorts of ways. I think one of the easiest is that you can think of statistical control as a way of estimating what we think the effect of one variable would be if we could somehow magically make everybody else exactly the same value on all of the other predictor variables. To see what I mean by that, let's return to our example in which we use a measure of the quality of the school a child attends and the number of hours they spend studying as predictors of their grade. Statistical control means that the regression coefficient for each of these variables is the estimated effect of that variable. If we could somehow make everyone have the same values on the other variable. For example, the predicted effect for hours spent studying is B equals 0.057. If everyone was in the same quality of school, we would predict that a student's GPA would increase by 0.057 for every hour they spent studying. And that effect would be statistically significant, right? With t equal to 3.483 and p equal to 0.001. And remember, by statistically significant, we mean that it's likely to be a real increase, not that it's actually a large or meaningful increase. Okay, just a little bit of review there. Let's keep going. Now, another way of basically saying the same thing is that we're estimating the effect of one variable holding constant all the other predictors. Now, what do I mean by that? You can think of it as the effect you'd see if you could somehow change people's values on one variable, say hours studying, but keep everybody's values on all of the other variables, such as school quality, exactly the same. Now, finally, as we said earlier, you can think of statistical control as mathematically removing any association between school quality and study hours so that you're just looking at the effect of school quality on its own apart from study hours and vice versa. As we'll see, that's probably the best definitive way of thinking about statistical control. To understand what I mean and how multiple regression accomplishes this, we'll spend the next few videos looking at how multiple regression works from a few different perspectives. Now, some of these are better, more accurate than others, but whichever makes sense for you is great, okay? See you in the next video where we'll look at multiple regression and residuals. Okay, bye for now.